Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. Hello once again, our most developed student. My name is Confident and welcome again to our Mathematics Grade 9, the ultimate guide, and this is for term 1. So we have already looked at some of the modules, and if this is your first time coming in contact with this channel, I will encourage you then to subscribe. You know what happens is when you subscribe, you are able to follow up on each and every lesson that we're doing in this channel. So this is what we already done, and we looked at whole numbers and we moved on understanding the whole numbers. We have already done an activity that will actually guide you in answering some of the questions that you're going to be expecting in your tests or if you're going to write an exam. So we have done that, and then in this next session we are going to be now looking at prime numbers. So now let's dive into this lesson in detail, because this is the purpose of the lesson, looking at the prime numbers. Now, the first thing that they will want you to know, not really to say, but to know, is the definition of a prime number. It is very important for you to know that definition. Now, what is a prime number? It says it is a natural number with exactly two factors. That's the key part. It has got two factors, says no more, no less. And then the number, it says then the number itself and 1. This means that 1 is not a prime number because it has only one factor, namely 1. So we're not talking about a prime number. We are saying it is a number that has got only two factors. The common one, they say 5. Think of 5 as a number. Now, what are the factors of 5? It's 1 and 5. So that's why they say it has only two factors. The number itself, which is 5, as well as 1, as you can see that. I can give you another one, 7. What are the factors of 7? It's 1 and 7. No other factor. Meaning there is no other number that can go into 7 except 1 and 7. You can bring other examples. Even if I can bring you 19. What other numbers, or what are the factors of 19? It's only 1 and what? And 19 itself. So all these are prime numbers. Now let's look at this activity here just to see how they were trying to trick you. This question here, 2.1, it says which one of the following is a prime number? Now A is 1. They told you this means that 1 is not a prime number, because if I say 1, what are the factors of 1? It's 1, and then what number can go into 1? It's only 1. So you can see that this repetition actually kinds of focuses, it actually does not follow this rule. Exactly two factors. Here we see 1 and 1 repeating, which means it's actually like one factor. So please, before they used to say 1 was a prime number, but now 1 is not a prime number. And then the next one is 2. Let's look at 2. The factors of 2 is 1 and 2 itself. So 2 can actually win this condition. What about C? It says 8. Now let's look at 8. What are the factors of 8? You've got 1 can go into 8, 2 can go into 8, 4 can go into 8, and 8 can go into 8. The moment there is more than 1, therefore it is not a prime number. So there is 1, 2, 3, 4. There are 4 factors of 8. So they're saying there must be exactly what? 2, no more, no less. So 8 is out. What about 9? 9 similarly, we have got 1 can go into 8, 9, we've got 3 and 9 itself. So how many factors are here? You see that there is 3 factors. So even 9 is out, because there must be how many? 2 factors, no more, no less. So these are the questions that they can bring, and it helps you to understand what we mean by prime factors. So remember, a prime factor is a number that has got only 2 factors, which is 1 and that number itself. Look at this one. It says express 144 as a product of its prime factors. This is a very common question, and there are 2 ways of approaching this question. The first one, they might say without using a calculator. So what you do this, and then you say I've got here 144 right? And then you are saying now, if I'm to express it as a product of its prime factors, the first thing you do is to, we call it, decompose the number. So in a way, you are trying to decompose it. So what do you do when you're decomposing? You are looking at the first factor of 144. You start from the smallest. Remember, 1 is not. So the next one is 2, because 2 is the first factor that can go into 144. So you are saying 144 divided by 2. So you have got 72 there. So you are like 144 over 2. 2 into that, it's 7 and it's 2. You see that? So that's what I'm doing. You can actually even use a calculator. And then next thing you continue to the next factor that can go into 72 is 2. 2 into 72, it is what? 36. As I said, it's not a problem to actually take a calculator, and then when you take a calculator, it can just simply give you the answer. So you're just simply saying 36 divided by 2 equals 18. Again, divided by 2, I get 9. So I will divide here. 36 divided by 2, I got 18. 18 divided by 2, I got 9. Now what's the next number that can go into 9? Is 3. 3 into 9, I get what? I get 3. Now what other number can go into 3 is 3 itself. 3 into 3. At the end of the day, you must be left with 1. Then it means you have reached the end. So if they're saying express this number as a product of its prime factors, what you then do, you are taking all these numbers. See that? All these numbers. So you are saying it's 2 times 2 times 2 times 2. How many times? 1, 2, 3, 4. Okay, times 3 times 3. So this then is your 144. You can quickly test it with the calculator just to see you never made an error. 2 times 2 times 2 times 2 times 3 times 3, which is equal to, you see that? So this is what they mean when they say express 144 as a product of its prime factors. But you can go further and say here in exponent form, how many 2's are here? You can see that there are 4. 2 to the power 4 times how many 3's? Is 3 to the power 1, 2. You see that? This is 144. This is the most acceptable way, because later you are going to be dealing with exponents, remember. So if you are going to be expressing it, it is better for you to express it in this form. So that's what they mean. But now, how about if you are in an exam, and I know they say don't use a calculator, but what if you want to use a calculator in this case? When you use a calculator, this is how you can simply check with your calculator if you are using the calculator which is different from mine. So what you do is you are going to press 144 and then you say equal to. Then from there you say shift. Somewhere around here where there is your B, if I'm not mistaken, this button, if you say shift, there is a fact which is FACT. If you press it, it is going to express it exactly like this. You'll get 2 to the power 4 and 3 to the times 3 to the power 2. This is the simpler way. The calculator will give you 2 to the power 4 times 3 to the power 2 directly. Remember what you do? You say shift and then you press, there is a button which has got this number fact. If you can press that on the calculator, it will directly give you that. So this is how, what they mean when they say express it as a product of its prime factors. Look at the next one here. It says express 8, 12 and 18 as a product of its prime factors. You can do it the long way, but I would encourage you to use your calculator. You just say 8 equal to shift fact, it will give you. But because my calculator can't do that, let me use the long way. 2 into 8, it's 4. 2 into 4, it's 2. 2 into 2, it's 1. So you can see that 8 is same as 2 to the power of 3. What about 18? I can do the same thing for 18 here. To say, for 12, the first one, 2 into 12, it's 6. 2 into 6 is 3. 3 into 3 is 1. Always make sure that the numbers on this side are prime numbers. You start from 2, then the next one is 3, then the next one is not 4, it's 5, because 4 is not a prime number. So these are prime numbers on the left hand side. there must be prime numbers. So what are those prime numbers? You start with 2, followed by 3, followed by 5, followed by 7, followed by 11. Usually they lay around such numbers. Don't find yourself now adding 4 here. 4 is out. Don't find yourself adding 6 because it's not a prime number. Don't find yourself here adding 8, 9, and 10. All these are off. Okay, so just be careful on that. When we have done that, let's look at, remember this was 12. What is 12? It's 2 times 2, which is 2 to the power 2 times 3 to the power of 1. You see, I'm already writing it in exponent form because there is two 2's and 1 3. That's why I'm saying 2 to the power of 2. Then the last one here is what? Is 18. If they say I need to express 18 as a product of its prime factors, you start by 2. 2 into 18 is 9, followed by 3. 3 into 9 is 3. 3 into 3, it's 1. At the end, you must have 1. So if I can have now my 18 is equal to 2 to the power 1 times 3 to the power of 2. So I think you can see now what I have here. So if I can take this out of the way here and say this is what I'm having. Alright, so now it says express this is as a product of its prime factors. Okay, so this is the answer that they'll be looking for. They will mark you that 1 mark, they mark you that 1 mark, meaning a product. You can see is 2 to the power of 2 times 3. They will allow it even if you say 12 is equal to 2 times 2 times 3. It's also fine. If you say 8 is equal to 2 times 2 times 2, still fine. Even if you say 18 is equal to 2 times 3 times 3. This is the starting point, but as I said, they prefer this one later for your exponents, and also you'll see why I prefer that one as we move on. So this is what we are having. Now let's look at the next part of this question. What it says. The next part says, because there is 2 parts in this, it says hence using your answer in 2.3, you see, calculate the LCM and HCF of 8, 12, and 18. That's where now it comes into handy. So you know our 8, if I can write down again, we said our 8 was equal to 2 to the power of 3. And then what was our 12? It was equal to 2 to the power of 2 times 3 to the power of 1. You can verify that, which is correct. And then our 18 is that one. 18 is equal to 2 to the power of 1 times 3 to the power of 2. Now when they say using the answer, hence, when they say hence means go previously, look at the answer you did, and then now using that calculate the LCM. So let's start here by looking at the LCM. Meaning, what does LCM mean? Lowest common multiple. Now when you look at the word lowest, always remember, for the lowest you do the opposite. You look for the highest powers. Lowest means, I will say, when you see the word lowest, do the opposite. Look for the highest powers. I will explain that shortly. What does it mean? So if they say look for the lowest common multiple, first thing first, look for all the numbers that appear. You can see that 2 is appearing, so you say 2 times, and then you can see 3 is appearing, you say 3. So it's only 2 and 3. So identify all the numbers that are appearing here. You can see that there is 2 and 3. Now I say then lowest means identify the highest powers. So when you see the word lowest, you do the opposite. Go and look for the highest powers after doing the first step, whereby you identify all the numbers that are appearing. You see you have 2 and 3. The highest power, you say that is 2 to the power of 3. I've got 2 to the power of 1, 2 to the power of 2, but these are not. I'm not supposed to tick there. So this is not the highest, it's 2 to the power 1. 2 to the power of 2 is not the highest, but 2 to the power of 3 is the highest. I write that one. Again, coming to 3, 3 to the power of 1, no, 3 to the power of 2 is the highest. Then the answer becomes that. Then it's up to you then to simplify it, you see. And then don't just leave it like that. You simplify it and say, what is 2 to the power of 3 times 3 to the power of 2? Then the LCM there is 72. Did you see that? So that's the first one. Then the next one is to find the highest common factor, HCF, highest common factor. Now with the highest common factor, you do a little bit different. Remember, highest, now I'll write it. You do the opposite. Highest means go and look for the lowest powers. You see the opposite on these numbers. So when they say highest, you look for the lowest powers. But what do you do with the highest common factor? You now look at the word common. You ask yourself, which number is appearing in all these three numbers? Which one is appearing? You can see that I have got 2 appearing in the first one, 2 is appearing in the second one, and 2 is appearing in the third one. So you can see that 2 is common here. So I'll say equal to 2 times, is there any other number that is appearing? I've got 3 here. Yes, I've got 3 here, but I don't have 3. So I see that 3 is not. So the only part here I have that is appearing in all the 3 is what? It is 2. And then after that, I'm looking for the lowest powers, or the smallest power. In this case, it's 2 to the power of 1. So that becomes the highest common factor of that. So you have answered the question. The LCM is 72. The highest common factor is 1. Now, I do quite a number of revisions when it comes to the LCM and HCF. I will encourage you to check the previous lessons. Remember, as I said, if you are subscribed, you are able to get all these lessons. Let's look at the next one. It says simplify the fraction, that one by using prime factors. Do not use a calculator. But let me tell you something. This is where you are actually going to use a calculator, because they are not going to find out. And what you do with the calculator, you take your calculator, because they don't necessarily need to see that division. So you're like, okay, if I'm to get 72, so you say 72 equal to shift, then you press that fact. Mine is not the right calculator, it's an older version. And then you find out what does it give. It will give you the number. I'll show you what the calculator will give you and how do you prove that you never used the calculator in a way. But let's do it the long way. 2 into 72 is 36. 2 into 36, it's 18. 2 into 18, it's 9. 3 into 9 is 3. And 3 into 3 is 1. Now, if you are looking at that, so therefore 72 will be equal to 2 times 2 times 2 times 3 times 3. Now, your calculator will just give you 2 to the power of 3 times 3 to the power of 2. This is what your calculator will just give you. So you just work backwards. So when your calculator gives you 2 to the power of 3, you start by saying 2 times 2 times 2, and then 3 to the power of 2, you say 3 times 3. You understand? So that's what you write. You write this step. You see, you write this step before this. It's a sign that you never used a calculator in any way. Because if it's always encouraged that you know the actual method. I'm not saying you don't need to know this method. It's a very important one, but sometimes it's just something that is wasting of time, you know. Now let's look at the next one. The next one is 504. But remember, you always need to test. Check your answers if you are correct. Don't be too much confident that your answer is right without testing. So what I mean is saying 2 to the power of 3 times 3 to the power of 2. Check that it gives you that. Now let's start with this one. 504 divided by 2 equal to 252. Divide by 2, that's the second 2, 126. Divide by 2, 63. So you saw that I said 2, it was 126. It was 504 divided by 2 is 12252. Divide by 2, 126. So here 2, I get 252. 2, I get 126. 2 here, I get 63. And then you can see that 2 cannot do, then we go to 3. 3 into that, I get 21, and then 3 in 21, I get 7 here, and 7, I get 1. You just have to know your multiple tables. So what we have here, it means 504, okay, is equal to, then you say 1, 2, 3. See, 2 to the power of 3 times 1, 2, which is 3 to the power of 2 times 7. See that? Now, this is where you write the final answer. Now, pay attention. They said 72 over 504 says simplify this fraction by using prime factors. So you're going to say where there is 72, it's 2 to the power of 3 times 3 to the power of 2. You see that? Over, and then for 504 you're going to say 2 to the power of 3 times 3 to the power of 2 times 7. See that? Equal to, then you are allowed now to say that 2 to the power of 3 will cancel the one at the bottom. The one at the top will cancel the one at the bottom. So what is left is 1. Don't say nothing. It's 1. This into that, it's 1. So what you have then, you have got 1 over, you can see there is a 7 there. So the answer becomes 1 over 7. If you want to do it the long or way, you're still allowed to say 504 is equal to, you write the longer one, which is 2 times 2 times 2 times 3 times 3, and then you come down here and say 2 times 2 times 2. I'm now looking at 504, and then which is times 3 times 3 times 7. Then you cancel 1 by 1 like that. See, when you're cancelling 1 by 1, at the end, when you're saying 2 into 2, it's 1, 2 into 2 is 1, it's 1, it's 1, it's 1. So it's 1 times 1 times 1 times 1 times 1, which is equal to 1 over 1 times 1 times 1 times 1 times 1 times 7, which is 7. So the answer becomes 1 over 7. Guys, this is what we mean by prime factors. So that's the next lesson that I'm going to be looking at. It's what? It's a ratio and rate. So this is the next lesson, and I will encourage you need to get hold of this lesson because it's very, very important. It's a good lesson, and most of the questions actually are based on this lesson. You can see there is a lot of practice that I'll be doing here, but what I will encourage you, ensure that you're subscribed. So this is the end of this lesson where we were looking at prime numbers, and you need to remember a prime number is a number that can only that has only two factors, which is 2 and the number itself, and 1 is not a prime number. So there are multiple choice questions that they are going to try to catch you up there. So this is the focus. If you are going to be following up on these lessons, I encourage you, I promise you that you will not have a problem with your term 1 work. This simplifies everything you need to know concerning your term 1 work. We've come to the end of our lesson. Thank you.